Hello everyone, this is Sanjay from Prolifix product team.
So in this demo, we are extending Panther by integrating with Python to bring advanced analytics and natural language capabilities for Panther screen. I used flights data to perform analytics and used Python's Spacey library to act as a natural language processor and to understand user questions on the travel to enable intelligent querying and a better analytics on the flights data. So now I'm going to my Panther screen. This is my screen which is loaded with flights data. I'm gonna show two ways of performing analytics on my this data. One is on the right side where user can select structured inputs like from drop downs from and to airport, and the second one is where user can ask their questions on these flights in normal English and system can able to answer the question. So now I'm doing the first way where I'm selecting from and to airport. I'm selecting flights from Los Angeles to Chicago on today, and I'm selecting departing range is 6 a.m. to 7 a.m. morning. So I can click search. As we can see, I do have find the results where one flight is departing at 6:30 a.m. So the instead of selecting manual inputs, we can ask a question in the natural language, and the system will answer with the help of Python's Spacey library. So now I am asking flights from Los Angeles to Tucson departing after 6 a.m. tomorrow. As we can see, we find the results. This is implemented by Python's time constraints and time filtering with the data. The next question I can ask is first connecting flights from Dallas to Charlotte. So I'm gonna paste my question here. So as I'm clicking check, it is giving the minimal connecting flights from Dallas to Charlotte, where intermediate airport is the New York. This has been implemented from Python's breadth first search algorithm, which will help finding the shortest path between the two nodes. And the next question I'm gonna ask is which which airline operates airlines with most flights operating today. So which will give the most flights operated by an airline. As we can see, United Airlines operating most flights, which is 14. This has been implemented by Python's inbuilt aggregating functions. Now I'll walk you through code how I implemented this thing. I'm opening my Python script for the screen, opening the Python code in the editor. So these are the modules I'm importing for this screen. Spacey library is the natural language processor, which will understand user questions. And this is the language, English language model I'm using Encore Web TRF. And I'm importing pandas for data processing and the collections for implementing breadth first search algorithm. Now the read travel grid function will read the data in the grid and convert into pandas data frame, which will easier to compare and check accurate comparisons with the Python code. And then next function is the interpret query, where I implemented Spacey library. So basically a Spacey library acts as a natural language processor, which will extract intents, location, geographic locations, date, time. All this will be extracted by this Spacey library. And now I'm extracting intent and I'm mapping to my Python handlers, which will do the job. The next function I'm going to show is the get paste connection function, where I implemented breadth first search algorithm. So in this function, each air like I where the whole flight's data acts as a graph theory, and each airport act as a node, and the flights between the each airport acts as a edge. So this algorithm will ensure that we'll get a route which with the minimal connecting time, and the and the time calculation also. Like the first flight should the second flight should leave from the airport after the first flight departing only. That condition we implemented in this function. And the get most airline function is like the airlines with the most operating flights is implemented by Python's inbuilt function like value counts, with which will count most flights per airline, and id max, which is a Python's built-in function which will give the top of this thing. So as we can see, this demonstrates how Python is powerful by providing rich built-in libraries for analytics and simplifies the complex logic to minimal, which will enable intelligent features on the existing Panther applications. And how wonder it is, like all of this code, I used Copilot to generate this most of the code initially. Then I customized it for the Panther integration. So as I'm concluding, we are not replacing Panther anymore. We are enhancing it with the modern analytics and AI capabilities to fit in this world.
Thank you.